Dear students, welcome for Learning Management System, Department of Collegiate and Technical Education. Subject is Analog Electronics, Unit 2, Transistors and MOSFETs. Myself, Mohan Kumar MR, Lecturer, HMS Polytechnic, Government Aided, Tumkur. This is the session number 15. In this session, we're going to discuss about FET definition, types and its symbol, construction of JFET, MOSFET definition, types and its symbols. Before going for today's session, let me have some quick recap of previous session. In previous session, we had a discussion on transistor which acts as a switch in CE mode, that is common emitter mode, and also we have discussed its applications. You all know that the transistor is a three-terminal device having base, emitter, and collector regions, which is used for amplification and switching purpose. The amplification means the strengthening the weak signal into strong signal. Either that signal may be a current signal or voltage signal. The switching applications, in switching applications, the transistor either it operates in saturation region or in cutoff region. Either it should be operate in open switch or it should be closed switch. When the transistor acts as a switch in CE mode, the voltage levels periodically changes between a low and high voltage such as 0 and 5 volts. It means that the voltage levels periodically change from low to high such as 0 to 5 volts. Andre periodic voltage levels 0 and 5 volts vary ಆಗ್ತಿರುತ್ತೆ. When it is in 0 volts, then the switch is said to be under open switch. When it is in 5 volts, the switch is said to be under closed condition. In switching application, the transistor operates either in cutoff region or in saturation region. We know that output characteristics of C transistor, which is operated in C configuration, there we're going to have three regions. One is active region, another one is saturation region, and other one is cutoff region. When the input of the transistor is high, the base current flows, hence the transistor operates in saturation region and it acts as closed switch. Andre input high ಆಗಿದ್ದಾಗ base current flow ಆಗುತ್ತೆ, so transistor saturation region ಅಲ್ಲಿ ಆಪರೇಟ್ ಆಗುತ್ತೆ, switch circuit closed switch ಆಗಿ ಆಕ್ಟ್ ಆಗುತ್ತೆ. ಗೊತ್ತಾಯ್ತಾ? ಅವಾಗ ಕರೆಂಟ್ ಕಂಡಕ್ಷನ್ takes place ಆಗುತ್ತೆ. When input is low, the base and collector current is 0. Input low ಆದಾಗ base current ಮತ್ತೆ collector current 0 ಆಗುತ್ತೆ. Hence, the transistor operates in cutoff region. Transistor ಆವಾಗ cutoff region ಅಲ್ಲಿ act ಮಾಡುತ್ತೆ. So, circuit condition open switch ಆಗಿ ಇರುತ್ತೆ. So, when the transistor is in low condition, low voltage condition, it acts as a open switch, that is 0 volts. When it is in high voltage, that is for 5 volts, it acts as a closed switch. Understood? Okay. Let me go for today's session, today's topic, that is FET definition. Before going for the definition, the name FET means what? FET is field effect transistor. Field effect transistor. Like BJT, FET is also having three terminals, that is drain, source, and gate. Okay? The name FET means the field which is created in the transistor in order to get the output current. Field FET is a voltage operated semiconductor device having three terminals, namely drain, source, and gate. Out of these three terminals, the gate terminal acts as a controlling terminal which can be used as amplifier or switch. It means here this is the FET image. Here we're going to have three terminals. One is drain terminal, another one is source terminal, and the last one is gate terminal. Out of these three terminals, gate terminal is acts as controlling terminal. ಈ ಗೇಟ್ ಟರ್ಮಿನಲ್ ಕಂಟ್ರೋಲಿಂಗ್ ಟರ್ಮಿನಲ್ ಆಗಿ ಆಕ್ಟ್ ಮಾಡುತ್ತೆ ಅಂಡ್ ದಿಸ್ ಎಫಿಟಿ ಕ್ಯಾನ್ ಬಿ ಯೂಸ್ಡ್ ಆಸ್ ಆಂಪ್ಲಿಫೈಯರ್ ಅಂಡ್ ಸ್ವಿಚ್. ಆಂಪ್ಲಿಫೈಯರ್ ಅಥವಾ ಸ್ವಿಚ್ ಆಗಿ ಈ ಎಫಿಟಿಸ್ ನ ಯೂಸ್ ಮಾಡಬಹುದು. This is the symbolic representation of FET. This is the symbolic representation of FET having three terminals. First one is drain, second one is source, third one is gate. The arrow symbol indicates the direction of electrons. Arrow symbol indicates the direction of electrons. Here, for this FET, the input is applied, that is VGS. The input voltage is applied to the gate and source terminal, that is VGS. If the input is applied to these two terminals, the output current will going to obtain from here, that is drain current ID. Here, the gate and source voltage is applied between the 2 and 3 terminals, that is source and gate terminals. The output ID current which is obtained from this terminal. FETs are also known as unipolar transistor. Unipolar transistor means the current conduction takes place only from the majority charge carriers. Either it may be holes or it may be electrons. Like BJT, here also we are having three terminals. BJT is a bipolar junction transistor. Coming to the classifications of FETs, FETs are categorized into two types. One is junction field effect transistor. Another one is metal oxide semiconductor FET. Again, this junction field effect transistor further classified as depletion mode FETs. And here, this metal oxide semiconductor FETs are further classified as depletion mode FETs and enhancement mode FETs. Again, the junction FETs are, again it has been classified into N-channel FETs and P-channel FETs. Again, the metal oxide semiconductor FETs are classified N-channel and P-channel FETs under depletion mode. In enhancement mode, it is also N-channel and P-channel enhancement mode MOSFETs. These are the symbols of FETs. This is a symbol for N-channel FETs having gate, drain, source terminals. Here, this one is the P-channel FETs having drain, gate, and source terminal. Here, in metal oxide semiconductor FET, the N-channel symbol is this one. This is also having drain, gate, and source terminal. Here, for P-channel FETs, having drain, gate, and source terminal. Similarly, in enhancement mode FETs, the N-channel FET MOSFET, MOS FET is having drain, gate, and source terminal, and P-channel FETs are also having drain, gate, and source symbol. This identification of these symbols can be done only by the indication of this arrow. This arrows indicates the direction of electrons. Okay, let's come for the construction of JFET. JFET means what? Junction field effect transistor. Junction field effect transistor. In junction field effect transistor, we are going to have two channels, that is N channel JFET and P channel JFETs. This one is N channel JFET and this one is P channel JFET. In N channel JFET, it consists of P-type material, P-type material in N-type substrate. This one is called N-type substrate. This one is called N-type substrate. Whereas in P-channel JFET, it consists of N-type material in P-type substrate. JFET is constructed using long channel of semiconductor material. This is the channel, long channel of semiconductor. This is the long channel semiconductor material. That is nothing but silicon or germanium material is inserted. Depending on the construction of process, if the JFET contains large number of positive charge carriers, means in the channel, if we have having large number of positive charge carriers, that is holes, then it is said to be P-type JFET. If the majority charge carriers are the holes, then it is said to be P-type in P-type JFET. If it has large number of negative charge carriers, then it is called as N-type JFET. If large number of negative charge carriers are present, then it is called N-type JFET. If large number of positive charge carriers, that is holes, is having this, then it is said to be P-type JFET. Ohmic contacts at each end are created to form source and drain connection. Here, these are the ohmic contacts. These are the ohmic contacts which are connected in the ends of this metal terminal to the semiconductor layer. This ohmic contacts acts as a junction for the conduction of current from semiconductor to the metal or vice versa. Ohmic contacts acts as a junction for semiconductor and metal for the conduction of current. Next, coming for the MOSFET. MOSFET means MOSFET or MOSFET. MOSFET is also having a three terminal, that is metal oxide semiconductor field effect transistor. It is also a voltage controlled field effect transistor that differs from a JFET in that it has metal oxide gate electrode which is electrically insulated from the main semiconductor, either N channel or P channel, by a very thin layer of insulating material, usually silicon dioxide. Metal oxide semiconductor is a three-terminal device. Andre metal oxide semiconductor MOSFET is a three-terminal device which differs from your JFET. Andre JFET ಗೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಇದ್ರ terminology ಎಲ್ಲ different ಇರುತ್ತೆ. So it is having a metal oxide in its gate terminal. ಈ ಗೇಟ್ ಟರ್ಮಿನಲ್ ನಲ್ಲಿ ಮೆಟಲ್ ಆಕ್ಸೈಡ್ ಇರುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ನಾವು ಮೆಟಲ್ ಆಕ್ಸೈಡ್ ಸೆಮಿಕಂಡಕ್ಟರ್ FET ಅಂತ ಕರಿತೀವಿ, ವಿಚ್ ಈಸ್ ಎಲೆಕ್ಟ್ರಿಕಲಿ ಇನ್ಸುಲೇಟೆಡ್ ಫ್ರಮ್ ದ ಸಿಲಿಕಾನ್ ಡೈಆಕ್ಸೈಡ್ ಲೇಯರ್. ಈ ಗೇಟ್ ಟರ್ಮಿನಲ್ ಮೆಟಲ್ ಆಕ್ಸೈಡ್ ಇಂದ ಎಲೆಕ್ಟ್ರಿಕಲಿ ಇನ್ಸುಲೇಟ್ ಆಗಿರುತ್ತೆ. ಯಾವುದರಿಂದ? ಸಿಲಿಕಾನ್ ಡೈಆಕ್ಸೈಡ್ ಇಂದ ಇನ್ಸುಲೇಟ್ ಆಗಿರುತ್ತೆ. This MOSFET is also having three terminals. Along with this, substrate is also considered as another terminal. This one is, first terminal is called as a gate, second terminal is called source, third terminal is called source. The first terminal is called gate, second terminal is called drain, third terminal is called source. This is the symbol of your MOSFET, having gate, drain and source terminal along with one more terminal called substrate. This arrow marks indicates the direction of electrons. Coming to the classification of MOSFET, the MOSFETs are categorized into two types. One is depletion mode MOSFET, another one is enhancement mode MOSFET. In depletion mode MOSFET, it is further classified as N-channel MOSFET and P-channel MOSFET. In enhancement mode, it is again further classified as N-channel MOSFET and P-channel MOSFET. These are the symbols of N-channel MOSFET. This is the symbol for N-channel MOSFET, having gate, drain and source terminal. This is the symbol for P-channel MOSFET, having gate, drain and source terminal. This is the symbol for N-channel MOSFET in enhancement mode, having gate, drain and source terminal. This is the symbol for P-channel MOSFET, having gate, drain, source terminal in enhancement mode. This is about today's session. The outcome of the session is the students should understand the definition of FET and its types, the construction of JFET, the definition of MOSFET and its types. Okay. After this, let me have discussion on multiple choice questions. The first question is the input impedance of ideal JFET. The input impedance of ideal JFET is, options that are given are, is impossible to predict. Second option is approaches unity. Third option is approaches infinity. And fourth option is approaches to zero. The answer is option C, that is approaches to infinity. As I told earlier, the impedance of FETs are high compared to your BJT. Input impedance. Impedance means resistance plus reactance. The input impedance is so high so that the FETs are much used in digital circuits. Second one is a unipolar transistor uses, options that are given is, first one, both free electrons and holes. Second option is only free electrons. Third option is only holes. And the fourth option is either one or the other, but not the both. The answer is D, that is either one or the other, but not both. Unipolar transistor means the current conduction takes place by only from the majority charge carriers, either holes or electrons. Let's come for the third question. The gate controls, first option, width of the channel. Second option, drain current. Third option, gate voltage. Fourth option, all the above. And the answer is D, that is all the above. The gate controls width of the channel also, drain current also, and gate voltage also. So The answer is all the above. Coming for the fourth question, a JFET can operate in option A, only depletion mode, option B, only enhancement mode, option C, both depletion and enhancement mode, option D, neither depletion nor enhancement mode. And the answer is option A. The junction field effect transistor can only operate in depletion mode because it has no enhancement mode. It is having only depletion mode. In MOSFETs, we're going to have depletion mode as well as enhancement mode. Hence, the answer is A. That is, a JFET can operate in only depletion mode. And the last question, a JFET is, the options that I have given is, it is a voltage control device, it is a current control device, it has a low input resistance, it has very large voltage gain. And the answer is option A, that is JFET is a voltage control device. You all know that JFET is a FET is a voltage control device, BJT is a current control device. Okay, I'll end this session. This is our team. This is the moderator, subject experts, and content developers team. Thank you.